Jai Hind, myself Dr. Ajay Pratap Singh, and I am Associate Professor in Department of Mechanical Engineering at Ajay Kumar College, Ghaziabad. Today I'll teach here the subject, the theory of machine. The subject code is uh, BME 603, which is affiliated to the Akgec University syllabus. So, in the today lecture, we'll discuss the different types of what is the machine, what is the mechanism, how the linkage working. So, different types of kinetic links and the types of the linkage, the difference between the machine and structures, and we can say the kinematic pair and the types of the construction. These are basic topics which cover the kinetic theory of machine. Basically, theory of machine, we can say the branch of normally the engineering science, which deals in the field of the analysis of kinematic and dynamic analysis of the machine or any parts of the. So, the theory of machine, we can say the combination of kinematic and dynamics analysis. So, the kinematics, we can say. It is the branch of theory of machine, we can say, which deals in the relative motion between the various parts of the machine. The dynamics, we can say, the forces, in this case basically the force and the machine which deals with the force and their effected, and while acting upon the machine parts in the motion condition for the dynamic cases. So, and another the kinetic. With the kinetic, we can say again it's we can say the branch of the theory of machine which deals with the inertia forces which arise from the combined effect of the mass and the motion of the machine parts. And other is the static. So, we can say the static is also deals with the force and their effect while the machine is the part at the rest. So, the mass of the part is assumed to be the negligible in this case of the statics. So, these are the basic conditions of the kinematics, dynamics and kinetics and statics. So, we summarize that the kinetics is the deals between the relative motion between the various parts of the machine. So, question is that what is the machines, right? Second thing is the dynamics. Dynamics, the force is when acting in the machine while upon the machine is in the motion in the parts. Kinetics, you can say, which deals with the inertia forces which arise from the combined effect and the mass and motion of the machine part. So, these and statics are the mass of the parts, and in case of the statics, we can the force and the effect of the machine and the parts in the rest position. So, these are the basic fundamental we are using in this whole the kinematics of machine, or you can the theory of machine part. So, what is the difference between the machines and mechanism? So, we have find out the various features like we can say the what is the definition. On the basis of the definition, we can classify or the define. Then on the basis of the purpose of this, we can define. Then energy and transmission, on the basis of we can define. Then what is the examples of this machine and mechanism, we can define. And the work output, what is the benefit of the work output of this machine and mechanism. So, we can say the mechanism is the combined of the rigid body designed to the transmit the motion and forces, and it is primarily used to change the direction or type of the motion. But in case of the mechanism, you can say the in case of the machine, a machine is the combination of mechanism, right? In the machine, there are a lot of the mechanisms required, so that work together and perform useful work and obtain the transmit to the power. So, we can say the machine is the combination of the different types of this mechanism, and these mechanism are we can say that transfer the force from to the transfer the force, or you can say the perform the useful work by the transmitting of energy in the forces. So, what is the purpose of those mechanism is used mainly for to transform the motion without performing any significant work. But in case of the machine, used to perform the useful work by the transmitting energy and the forces as well. So, energy transmission does not transmit or convert in the significant power in the case of this mechanism, but in case of the machine, the transmit or convert the energy to perform the mechanical work in case of the machines. What is the example? So in case the slider crank mechanism, you can see. So the slider crank mechanism, you can see here, that is one crank. This is the connecting rod. This is the piston. Is a fixed here. Right? These are cylinder parts, and that cylinder the crank is fixed here. So these are one part is the mechanism. This is the one mechanism. So these we can see, you can see here that the link number 1, we can say the fixed, all the fixed point is the link number 1. This is the link number 2, link number 3, and this piston is the link number 4. So there are 4 linkage in this case, or we can say, and that these are the crank. These link, suppose O to A is the crank, A to B is, that is the connecting rod. This 4 point, that is called point number B, is the piston, and these parts is the, you can say, the cylinder. Right. So these are the combination, you can say. To suppose the slider crank mechanism, the 4 bar link. So these are the slider crank mechanism, you can say the 4 bar mechanism. These are the mechanism, but these mechanism are used in any machines like the lathe machine, the drilling machines, the car engine, the sewing machine. So we can perform these mechanisms like the rotary motion is converting to the reciprocating motion. So in case these mechanisms, slider crank mechanism is the useful, these mechanisms are used to in the lathe machines or the drilling machines or the car engine. These are transfer the power, the transmit the power and energy. That's case of these different types of machines. So that is called the these are the mechanisms, and the combination of these all and work output in terms of the energy transmit, that is called the machine. So work output, there is no significant output in case of the mechanism, but in case the in case of the machine, it produce the work output by the utilize input power. So mechanism is just a motion transmitting system, but where a machine is a system of the mechanism to design to perform the specific task. So we can see here that the mechanism, we can summarize all these 5 points: the definition, the purpose, the energy transmissions, and the examples, and the work output. On the basis of that, we can summarize that the mechanism is just a motion transmitting system, but in case of machine is a system of mechanism to design to perform a specific task. So these are summarized from the machine and mechanism. So you can see here that the one reciprocating steam engines, and you can see the kinematic link or the element. Each part of the machine which moves relative to some other parts is known as the kinematic link or the simply link or the element. So we can define the link, kinematic link, element or the simply link. We can say that each part of the machine, right, which moves relative to some other parts is known as kinematic link, simply link, or you can say the element. So you can see here that's the reciprocating steam engine, right. So here you can see that a different type of these parts. So here you can see that is the crankshaft, right. This link is the crank. This point is the big end bearing, that this is a flywheel. These are the connecting rod. These are a small bearing here. Then engine frame, then piston and the cylinder. So these you can see each and every part is connected to transfer the motion or the in terms of the relative motion. From here you can see these are relative to this part, right. The crank is relative to the connecting rod. So these are the 2 links, right. So you can say that is a 2 link in connecting between the crank and connecting rod, then connecting rod to the piston, and one is the frame. So there are 4 linkage in this case, and you can transfer, you can say these are moves relative to some other work. So we can say link or the element need not to be a rigid body, but it must be a resistant body. A body is said to be a resistant body if it is capable of transmitting the required forces with negligible deformation, right. And thus the link have the 2 following characteristics. You can say it should have the relative motions, and it must have a resistant body. So please remember that the kinematic link need not to be the rigid body. If rigid body is there, so in that case these are the not a mechanism, these are the structure, right? So please remember that the kinematic link is not need to any rigid body, it must be the resistant body, and resistant body you can say that the resistant body, it is the capable to transmit the required force in the negligible deformation. During this transmitting force, the deformation is negligible, and there are two main characteristics of this the kinematic link. You can say that it should have the relative motion, and it must be a resistant body. So type of link you can say that is the rigid link, second is the flexible link, third one the fluid link. So what is the rigid link? You can say the rigid link is one which does not undergo any deformation, right, while the transmitting the motion. Strictly speaking, the rigid link you can say that the rigid link does not exist. In actual practice, the rigid link does not exist. So we can say, however, in case of the deformation of connecting rod, crankshaft, or you can the reciprocal stimulation is not applicable, they can be considered as the rigid link. So these are the parts of the rigid link. Then second thing is the flexible link. You can say the flexible link is one which is partially deformed in a manner not to affect the transmitting of motion. For example, you can say the belt, rope, chain drives, chain and wire drives, and the wires are the flexible link and transmit the tensile forces only. Then the fluid link. The fluid link is one which is formed by having a fluid in a respectable and the motion is transmitted through the fluid by pressure, pressure or the compression. In this case, we can say that the hydraulic press and jack and brakes are the fluid link. So you can see in this next slide that the types of the different types of this the linkage, that you can see here that the rigid link, there is no solid, you can say, then fixed link, then flexible link, then again the flexible link, these are the fluid link, you can say, hydraulic cross section link. So these are basically, you can say, the different types of the linkage you can see in this photographs. The rigid link, there is no deformation in this case, right? The flexible, then the chain drives, belt drives, rope and belt and pulley, chain and rope drives. These are the flexible links, right? So these are the hydraulic links. You can say fluid links, which transfer through the fluid power, or we can say the compression. So difference between the machine and structure. What is the basic difference between the machine and structure? You can see here in the figure that this figure is represent, that is the machines, and this figure is represented as the structures. So you can see that there are four you can say the features. Main features is that the motion, what is the motion in case. Second is, we can say, the what is the purpose, then what is the examples, and some the force transmission. So on the basis of the features we can define the machine and structure. So machine, we can say the motion in the case of the machine, parts moves relative to each other, right? In the machine, each parts of the move relative to each other. But in case of the structure, there are no relative between the parts. There you can see here that is no relative between any parts. You can see that is no relative between the any parts, right? What is the purpose is there? In case of the machine, it converts the energy to perform the useful work, right? But in case of a structure that is supposed to load and restrain the forces. Examples: lathe machine, car engine, and the crane is and other examples of these machines. But in case of structure like bridges, building, dams, these are the parts of the structures. And the force transmission, that transmit the force and motion in case of machines, but in case of structure, withstand the force without the motion. So these are the basic difference we can see here. These are the basic difference between the machine and structure. So the parts of the machine moves relative to one to another, and where we can say the member of a structure do not move relative to one another, and the machine transform the again the available energy into the some useful work, whereas is structure no energy transform into the useful work. The link of the machine may transmit both power and the motion, while the member of a structure transmit forces only. So please remember, in case of structure, it transmit the forces only, not a motion. But in case of machine, it transmit the both forces and motions. Now come to the kinematic pair. So kinematic pair, we can say that the terms the pair. Pair means joining of two elements, we can say. So if the two links are the element of the machine, when contact to each other, right? So we can say that is form the pair. Suppose these are the one link, right? These are the one link, and then connected to another link. In between that the motion is performed. So we can say that is the kinematic pair. So if the relative motion between them the completely or successfully constant, that is you can say the definite direction in case of the constant motion. So the pair is known as the kinematic pair. So you can see that is the one link is there, then another link there, and in between the motion is connected. So here that the pair of this. So one link is connected and second link is connected, in between that motion is performed. So we can say that is the kinematic pair. So the different types of the kinematics pairs, we can say there are you can say the three basic classifications of this kinematic pair. One is according to the type of the relative motion between the elements. Second is the according to type of contact between the elements, and third one is according to type of the closure. So there are the basic three kinematic pair classification. On the basis of, we can say, the relative motion between the elements. In that case, there are 5 subcategories. One is the sliding pair, then turning pair, then rolling pair, then screw pair, and spherical pair. In case of, I will discuss in the next slide one by one. So in case of the contact between the elements, that is the lower pair and the higher pair. And in case of the according to type of the closure, that is the self close and the force close. So these are the basic criteria of the kinematic pairs. On the basis of, you can find out the pair, all the pairs of this combination, the lower pair is there or higher pair. So I will discuss the what is the lower pair and higher pair also. So you can see here that the according to type of the relative motion between the element, the sliding pair, right? Sliding pair, we can say, is the parts of the lower pair also. Lower pair means the one part is connected to the other part is a surface contact, right? If any bodies connect to each other and that the surface contact is there and motion is provided, so we can say that is the lower pair. In case of the higher pair, the one part is connected to another pair, and in between that the connected is the point contact or the line contact. In that case, that the parts is known as the higher pair. So higher pair examples you can say that is a belt and pulley is the line of action. So you can say that is the line contact. If wheel of the chair of the wheel is connected rolling in the surface, so we can say that is the in the line follower passing, or we can say that the cam and follower, you can say that is the line, point contact, or we can say that is the gear connecting between the two gear transmitting the motion, the line of action is there, so you can say the line contact. So in that case the gear is the higher pair. So but the lower pair, the surface maximum connection between these the elements, the two elements, we can say that is connected to the surface pair. So we can say that the sliding, we can say that is the lower pair. So you can see here that is the square pair. You can see the motion between that. So you can see here that the slider bar, the square bar in the square hole move to sliding inside. So the square bar move inside the properly. So you can say that the motion in the only one direction, you can say. So you can here both forward and backward. So this is called the sliding pair. But in case of the turning pair, the rolling bar in the rolling hole, and you can see the rolling bar here. You can see the rolling bar. So these are rolling bar and fixed with the collar. So only one direction is possible in the case. Right? These are called the turning pair. This turned about this axis. Right? So again the rolling pair, you can say that the one ball in this case, so is rolling inside. The ball is connected in all these rolling pair. Then screw pair, that's you can see here that the screw, lead screw inside, so you can move the lead screw. And again the spherical pair, so that I think you can see here that the side mirror of the car is the best example. You can say the pen stand are the best example of the surface pair. So you can say that the spherical pair. That these are the according to the type of the relative motion between the elements. You can say the sliding pair, when the two elements the pair are connected in such a way that can only slide relative to each other, and the pair is known as a sliding pair. Like for example, you can say the piston of the cylinder crosshead and guide the respecting steam drum, ram and it guide in the shaper, tail stalk and on the lathe bed, we can say are the example of the sliding pair. And we can say the sliding pair has a completely constant motion, right? Sliding pair is the completely constant motion. Now come to the turning pair. The turning pair, when the two elements of the pair are connected in such a way, you can say we can turn or revolute about the axis of the another link. So we can say that is the turning pair. So you can see here that if the collar is not here, right? So you can rotate and slide also, but the sliding motion is fixed with the help of collar bearing, right? You can see that is fixed with this collar, right? So these are only turned inside of the one axis. A shaft with the collar with the both ends fitted. You can see the shaft with the collar of both ends fitted and into the circular hole, and the crank shaft in a journal bearing in the engine in the lathe, and the spindle supported the head lathe of the stock, and the cycle wheel turning over their axle, etc. are the example of the turning pair. And the turning pair is also known as the completely constant motion, right? So rolling pair, we can say the two elements of the pair again the connected in such a way that one rolls over the another to fix a link. The pair is known as the rolling pair, and you can see in this figure the ball, right? These are the rolling pairs. So ball and the roller bearing of the example of the rolling pair. Then screw pair, when the two elements of the part in the connected in such a way, you can say that the one element can turn about to other by screw threads. The pair is known as the screw pair, and you can say the lead screw of the lathe bed with the nut or the bolt is example of the screw pair. Spherical pair, again we can say when the two elements again the connected in such a way that one element with the spherical shape turns with the, or you can share about the other fixed element, and this is the form of the part of the spherical pair. So the ball and socket joint is the attachment of the car mirror or the pen stand is the example of this spherical pair. So you can see here that the part of the spherical pair, right? So lower pair, you can say the lower pair we can when two elements of the pair according to type of the contact between the elements. So we can say the lower pair when two elements of the pair have a surface contact, means pair two elements connection between that is the surface contact when the relative motion take place and the surface of one element slides over the surface to another. So the pair is known as the lower pair. So you can see in the previous slide that the sliding pair, turning pair, screw pair are the form of the lower pair, right? Higher pair, when the two elements of the pair have a line or point contact, when relative motion take place and the motion between the two elements is partially turning and partially sliding, then the pair is known as the higher pair. And the pair of friction disc or the tooth gearing, belt and rope drives and ball and roller bearing and cam and follower is the example of higher pair. Again the according to the type of the closure, those there are two types, one the self and the force close. So self, when two elements of the pair are connected together mechanically in such a way that only the required kind of relative motion occurs is known as the self close. The two lower pair are the self close pair. So you can see here that is the self close and the force closure of the lower pair. So force closure when the two elements of the pair are not connected mechanically but in kept contact by the action of external forces. The pair is known as the force closed pair, and the cam and follower is example of the force closed pair, and it kept contact the force closed by spring by the gravity. So you can see that is these are the example of this force closed pair. And are the you can case in case of all the lower pairs are the self closed pair. So lower pair in the surface contact. So you can see here the different types of this the classification of again the kinematic pairs. So you can see the revolute pair, prismatic pair, screw pair, planar, spherical, cylindrical, ball and roller bearing with the higher pair. So these are the examples of this, because the ball and roller bearing connect with the point contact. It is connected rotating by 1 to 1. So you can see the ball is connected with the bearing at the time like this is the point contact, right? So particular point is connected. So at that time that is the point contacted. So you can say that the ball and roll bearing is the higher pair. Now what is the types of the constant motion? You can say there are three types of constant motion: the completely constant motion, incompletely constant motion, and third one the successfully constant motion. So completely constant motion you can say when the motion between a pair is limited to definite direction, you can say irrespective of the direction of the force applied, then the motion is said to be the completely constant motion. For example, we can say that the piston and cylinder in a steam engine form a pair, and the motion of piston limited to different direction. So we can say that is it will move to the only reciprocating motion and relative to the cylinder respectively of the direction of the motion of the crank. So you can see in this figure that these are the movement of the force in the shaft with the collar in the circular hole. These are the circular hole and these are shaft, and these are the collar in the both in the fixes. So when force is applied, right, in the only one definite direction is the possible, right? So only he is rotate above this axis. This one only the slide is possible. The sliding motion is the possible in this case of the square bar in the square hole. So in completely constant motion, we can say in completely constant motion when the motion between the pair can take place more than the one direction. So the motion is called the incomplete constant motion, and the change in this direction of the impressed force may be alter the direction of the relative motion between the pair. So you can see here the circular bar in a circular hole in so in that case in this figure you can see that it is the round hole is here and that is the shaft. If you fix up in this side and force is applied, it will slide also and it will rotate also. So there are two motion is possible in this case. So in figure you can say the example of the incompletely constant motion, as it may be either rotate or the slide in the hole, and these both motions have no relation with the others. Next one is the we can say that the successfully constant motion. The successfully constant motion we can say when the motion between the two elements forming a pair in a such a way the constant motion is not completely itself. So, but by some other means we can say the motion is said to successfully constant motion. Suppose you can say the consider a shaft in a footstep bearing, and so in this figure you can see in this figure the one is the shaft and load is applied in footstep bearing. So we can say this is case of the incompletely constant motion. But if the load is placed in the shaft, right? If the load is placed in the shaft to prevent the axial upward movement in this direction, so then the motion of the pair is said to the successfully constant motion, and the motion of the IC engine valve like the these are we can say the kept on other seat like by the spring on the piston reciprocating inside the engine, and the cylinder are also be example of the successfully constant motion. So shaft you can see in this figure that the footstep bearing, these are the shaft, these are bearing, the load is applied inside. So these are you can see the consider the shaft in the footstep bearing. The shaft may be rotate in the bearing, or it may be the move upward. So there are two options possible. You can rotate, or you can the move upward and downward. So this is the case of the incompletely constant motion. But when you apply the external load in the shaft to prevent the axial upward motion, the shaft then motion of this pair is set to the successfully constant motion. So we can say we can restrict the one motion through applied the external forces. So there are three types of the constant motion we have discussed here. One is for the successfully constant motion. Second is neither incompletely constant motion, and third one is the successfully constant motion. Right? Completely constant motion. Second one is the incompletely constant motion, and third one is the successfully constant motion. So we can summarize this. The completely constant motion, the motion is only in the one direction, right? In incompletely constant motion, that is motion in the two direction, more than one direction, say, so that is the incompletely constant motion. And successfully constant motion, that all the successfully constant motion is the part of incompletely constant motion, and when we apply it to the force and restrict the one motion, and it convert to the successfully convert to the constant motion. So you can say that is a successfully constant it convert to the completely constant motion. So in that case, you can say that is the part of the successfully constant motion. So in this lecture, we have summarized in this today lecture, so summarize the different types of the kinematics. What is the kinematics? What is the dynamics? What is the kinetics? And what is the dynamics? Statics, kinetics, and statics. Then we have discussed the kinematic pairs, kinematic links, and the different types of this the constant motion, different types of this you can say and other one part is defined here, that classification of the kinetics we have discussed. I hope you have learned all these things. If you have any problems, please discuss and see the mail ID is given. So thank you so much for this for the basic of this the theory of machine part of the linkage and kinetic. So next part we have discussed in the next lecture. We will discuss, and you can see how to calculate the different type of the linkage. On the basis of linkage, you can find out it is the machines or the structures. You can find out there are some formula, the Kurzweil criteria. We have discussed the degree of freedom and how to calculate the degree of freedom for the planar mechanism and independent mechanism. So we can find out, and then I'll further next lecture discuss. Thank you so much.